Dear student, in previous class, he was discussing regarding the introduction to the block diagram and also the what are the rules used for reducing the block diagram and find the overall gain of the system. We know that block diagram and also the signal flow graph can be used to represent the control system graphically in control system graphically. In control engineering, to show the function performed by each component, we commonly use a diagram. We commonly use as a diagram called block diagram and also the signal flow graph. These are the diagrammatic method of representation of the control system, because control system is a collection of various physical components. To show the function performed by each component in a control system, we go for using these diagrammatic methods, block diagram and also the signal flow graph. In this particular session, I'm going to discuss the other rules of block diagram algebra. The rules can be used to reduce the block diagram and also find the overall gain of the system by using the rules of block diagram algebra. In previous session, I was discussing some of the important rules from rule 1 to rule 4. The rule 1 means it is a combine the blocks which are connected in cascade. Rules second means combine the parallel blocks. If the blocks are connected in parallel, then we need to how to combine those block I was discussed in the previous session. So, and also the moving this branch point ahead of the block, moving the branch point before the block. These rules can be discussed in the previous session. So, today's session, now going to discuss next rules of block diagram algebra is moving the summing point ahead of the block. Here, suppose this is the summing point. You know that the summing point, branch point, and also the take up point or branch point or take up point, summing point and blocks. These are the is the element for constructing the block diagram. Here there is a summing point. The summing point is used to add two or more signals. In order to add the two or more signals, we go for using the summing point. Similarly, block point is a block is a symbol for indicating the mathematical operation to produce the output signal. When the signal is input, automatically it will produce as the output. So this is the symbol for mathematical operations. Usually, the transfer functions are placed inside the block. And the summing point here A is the input, B is the input. The output is here there is a arrow head sign at the arrow head indicates the signal should be added or subtracted. Here the signal at A arrow is plus, so here also A, therefore A plus B. The output of this summing point is equal to A plus B. Now this A plus B is the input for this particular block. Then what is the output of the block? We know that the output of the block is equal to the input into transfer function. Now, inside the block, usually the transfer function is present inside the transfer function is usually present inside the block. Transfer function is present inside the block. The output of the block is equal to input into transfer function. This is the standard relation because you know that a transfer function is equal to output divided by the input. If I want to find out the output, I cross multiply TF with the input. That is what output of the block is equal to. If I know the transfer function, if I know the input, then I can calculate output is equal to, this is the formula. Therefore, output of this particular block is equal to input into transfer function. The output of this is equal to A plus B into G. The C of S is the output and R of S is the input. Therefore, this is the output, this is the input. The rules of block diagram algebra state that if any modification made onto the diagram should not alter the input and also the output in such a way that we need to alter That is, if I move this summing point after the block G, then what will be the, suppose this is the summing point. So if I move here, now this is the modified diagram. Now output is equal to what? A is the input. So output I expect these things. So but according to this, what is the output of here? The output is here A into G, because input is A, transfer function is G, A into G. Input into transfer function is equal to output of the block. So the output of the summing point is equal to AG plus B. AG plus, according to this diagram, if I move here, then this is the answer. Oh, but I should express, I should get the result. Output is A plus B into G. In order to get this, this is wrong. Oh, in order to get that, we should multiply this branch. That is what is here I should get A plus B into G. Here I should get A plus B into G. This is the answer we should get. So in order to get this A plus B, here I should get, what is the A plus B into G. In order to get this, we should multiply this particular B branch must be multiplied by this transfer function. Now what is the here? Input is B. The output of the block is equal to, the input is, suppose here there is an input. So now this is the G. The output of the block is now B into G. The input is B into G, BG. Now what is the output of this here? Therefore output is equal to here AG plus B, BG. If I remove the G outside, then what will be the A plus B into, now this is the answer. Now same answer. When I move the summing point in the block diagram while reducing the block diagram, I will go for reduction in order to find the overall gain of the system by using the rules of block diagram algebra. When I want to move in that particular situation, if I want to move the summing point after the block, I should remember this particular, whatever the branch moving, that branch gets be multiplied with this transfer function. No, that is what I mentioned the G here. Oh, that is the rules of this particular rules of this rule 5, rules of block diagram. This is a very important rules of block diagram algebra. Next rules. Now what is the next rule? The rule 6 is move. If I move the summing point, if I move the summing point, if I move the next rule is, if I move the summing point before the block, that is the next rule. Next rule of block diagram algebra is, if I move the summing point before the block. Now this is the block diagram, or here there is a block, here there is a summing point. If I want to move this particular summing point before the block, and this is the diagram. If I move the block, this summing point before the block, this is the modified diagram. According to this, so A is a signal, B is a signal. Output is equal to of the summing point is equal to A plus B. Here, what is the answer? Is equal to A into A plus B into G is the result. But I should expect the AG plus B. The rules are framed such that if any changes made on the diagram should not alter the input and output. The desired output is A, here input is A, output is AG plus B, but here desired out, but obtained result is A plus B into G, but I should expect this result. That is what I should multiply here. I should this particular, after moving this summing point before the block, then I should here multiply this branch. B branch must be multiplied by 1 over G. The B branch must be multiplied by 1 over G. 1 over G is the transfer function. No, this is the transfer function. 1 over G is the transfer function. No, Therefore, here the suppose B is the input. So, what is the output of the year? The output is equal to the year B into G. Output of this particular block input is B. Suppose input is equal to B. The transfer function is G, 1 over G, and the output is equal to B by G. Now, what is the year? The output is equal to A plus BG, B by G. A plus B by G. Now this is quantity is the input for this particular block. Oh, and output is equal to what is the output of A plus B by G into G into G. Therefore, if I multiply this G with AG, then B by G into G. B by G into G. Therefore, G and G gets cancelled. The answer is I should expect this instead of this. So I should expect now AG plus B is the answer. This is the desired result. So this is the important rules of block diagram algebra. Moving the summing point before the block. Oh, we should multiply the corresponding branch. The corresponding branch is this B branch must be multiplied with the 1 over transfer function. No, 1 over this is the transfer function 1 by G. 1 over this value. This is not seeing. This is the 1 over the G. 1 by G is the transfer function. No, I should understand this rule is also very important when we go for reducing the given block diagram into find the overall gain of a system. This is also very important rule. So you have to study, and also remember this rule. Next rules of block diagram algebra is rule 7. No, rule 7 rules state that interchanging the summing point. Oh, now these are the two summing point. Oh, it is used to add the A signal and B signal. Oh, the result is output is equal to A plus B. C is the signal. We need to subtract C from A plus B. Now this is the output. Oh, this is the input. Oh, now if I interchange these two summing point. Oh, if I interchange by interchanging these two summing point. Oh, the result is the resultant diagram is this is. So here after adding subtracting the C from A, we go for adding the B, then also we will get the same result. So that is equal to A minus B, A minus C, plus then we go for adding A minus C plus B. It is also as equal to same answer. Oh, if any changes made on the diagram should not alter the input-output relation. Oh, this is the rules of the rules are framed in such a way that if any changes made on the diagram should not alter the input-output relation. Oh, this is the very important. So that is what if any changes made on the block diagram should not alter the input also same, output also same. In likewise that we should alter. Oh, in rule 8, next rule is rule 8. Oh, if I split the summing point, then also the result will not changing. If I split the summing point, oh, split the summing point in such a way that results will not changing. Input and output relation should not change. So this is the summing point. We use it to add the A with the B, and then we go for subtracting C from A plus B. Now this is the output. Oh, therefore here, if I split the summing point, oh, here, and then the result also we should expect the same result. Oh, this is the way we should write the diagram. So these rules are very important. So the next rule is eliminating the eliminating the feedback, negative feedback element or positive element. That is also very important rules of block diagram algebra. This is next rule is elimination of the negative or positive feedback loop of the closed loop system. Regarding the closed loop system, I have discussed in the merits and demerits, advantage, disadvantage, examples. So those things I have discussed in the beginning chapters. Therefore, here the closed loop system, G of S is called as a open loop transfer function, H of S is called as a feedback transfer function. Now, what is E of S is called a actuating signal. B of S is called as a feedback signal. The B of S is called a feedback signal, actuating signal. So, and this is my feedback transfer function. Open loop transfer function, G of S is called these things. You should remember. Now, the BFS is called as a feedback signal. Now, what is the BFS value? The input to this particular block is H of S. So, C of S. So, and transfer function is H of S. C of S input and H of S the transfer function. No. Similarly, what is E of S? So, E of S is equal to what is the difference in RFS minus B of S? So, now what is B of S value? I have to substitute here. B of S is equal to C of S into H of S. So, next similarly, what is C of S value? I want to calculate C of S. So, what is C of S value? E of S into G of S. So, input into transfer function. No, input is the block is E of S. So, transfer function is G of S. So, therefore, what is E of S value now? E of S value is R of S minus ES into HS is the E of S value. And GFL as this is I have written now. Similarly, here if I multiply GS into RS, so this is the quantity CS HS into GS. So written now. If I take this term on left hand side, and CFS plus CFS HS into GFS. So in that term, I have taken CFS outside. Therefore, 1 plus GS into HS. 1 plus GS into HS is the term after taking the CFS outside. This is the term. Now, on right hand side, RS into GS. So, I want to get the closed loop transfer function. Closed loop transfer function means CFS divided by RFS is the closed loop transfer function. Therefore, CFS divided by CFS cross multiplication, CFS divided by RFS is equal to GS divided by 1 plus GS into HS is the transfer function. While reducing the block diagram, if any block in this form, then I should represent in this form. What is the value of this is equal to GS divided by 1 plus GS into HS. So if it is negative feedback, that is called negative feedback element. If it is negative feedback loop, then 1 plus GS into 1 plus GS into HS. So if it is positive feedback, then what is the, if it is positive feedback, here there is a plus, minus, there is a plus per if it is positive, then what is the E of S value? E of S is equal to R of S plus B of S. So here also plus. So here also plus. So this is also plus. So if this term taken left hand side, then this becomes negative. Therefore here also there is a negative. If it is plus or minus, here positive. If it is plus, it is a negative. Now this is the elimination of negative or positive regarding elimination of the negative or positive feedback loop of the closed loop system. This rule is very important. In some time, the examination, you will get a question also, find the or derive the closed loop transfer function of the closed loop system. This is the transfer function of the closed loop system. CFS divided by RFS is equal to GS divided by 1 plus GS into HS is the standard formula. We should remember. Next rules are critical rules. So those things I have discussed in the examination. You will get a question on critical rules. Also explain the critical rules. So there are two rules of critical rules. So if there is a summing point, and also the takeoff point. If there is a summing point and also the takeoff point. Now, if how to move the summing point after the takeoff point. How to move the summing point after the takeoff point. And how to before the timing point. Those are called as the critical rules of the rules of block diagram algebra. Those rules are not usually used for rarely using for reducing the block diagram and find the overall gain of the system. But examination get a question, explain the critical rules. So you have to go through the prescribed book or any book. So we'll get an explanation regarding the critical rules. So you should remember those things also. Those rules are sometimes rarely useful while reducing the block diagram. So this is regarding the rules of important rules. In my sessions, I have explained the important rules necessary for reducing the block diagram and find the overall gain of this system. But in next session, I'm going to discuss the how to reduce the given block diagram and find the overall gain of a system with an example. So thank you for listening.